Thank you for joining New Jersey Audubon's webinar on healthy forests, the second in the series. I'm Eileen Murphy, Vice President of Government Relations at New Jersey Audubon. Welcome. Before introducing our guests, I'll take a moment to go over some of the webinar housekeeping features. You'll notice there's a Q&A where I'll ask you to post your questions as you think of them. We won't be taking questions immediately after each presenter. Rather, they'll be addressed at the end of the entire webinar. And Drew Tompkins, who is New Jersey Audubon's Policy Director, will be scanning the Q&A and putting similar questions together so that to enable the panelists to answer as many as possible. If your question has been answered by a subsequent speaker, we'll make a note of that as well. The webinar is being recorded, so colleagues who could not attend in person can listen at another time. And also, I hope you'll attend the additional webinars that we're planning for the fall. One will be focused exclusively on carbon sequestration and storage of New Jersey forests, and one on controlled burning. And now it's my great pleasure to introduce our panelists in the order that they'll be presenting. Mark Ashton is Professor of Silviculture and Forest Ecology, Director of Yale Forests, and Senior Associate Dean for the Forest School at the Yale School of the Environment. His research focuses on biological and physical processes governing the regeneration of natural forests and the mechanisms underlying the diversity of forest ecosystems and their adaptability to climate change. He conducts his long-term research in both temperate and tropical forests and has worked from New England to Sri Lanka, Canada to Brazil. Dan Duran is assistant professor in the Department of Environmental Science at Rowan University, as well as the naturalist for Scotland Run Park, which is a 1,300-acre nature preserve at the edge of the New Jersey Pine Barrens. He's published multiple research papers on agricultural entomology, biodiversity, and molecular phylogenetics. He's described 10 new species of insects previously unknown to science. He has a BS in environmental studies, an MS in entomology, and a PhD in evolution and ecology. In between his degrees, he's also worked for the Natural History Museum in London, the Smithsonian Tropical Research Institute in Panama. He's a co-author of the book, A Field Guide to the Tiger Beetles of the United States and Canada. Matthew Olson is an assistant professor of environmental science at Stockton University. His educational background is the ecology and management of forests and woodlands. His research addresses how trees and forest plant communities respond to environmental variation and disturbance. And much of his research focuses on tree regeneration and stand dynamics in managed temperate forest. The goal of his research is to help inform forest management actions, including strategies for adapting to climate change and associated forest health threats. And finally, but not last, Richard Lathrop, who is the Johnson Family Chair in Water Resources and Watershed Ecology in the Department of Ecology, Evolution, and Natural Resources at Rutgers University. He is also the he also is the director, of the Grant Walton Center for Remote Sensing and Spatial Analysis at Rutgers. His research program works to integrate the insights of ecology and geography with the application of geospatial information technology to improve our understanding of coupled human environmental systems. Collaborating with multiple partners, he works to translate that understanding into effective and appropriate techniques to improve on-the-ground natural resource management and land use planning. So without further ado, I'm going to turn over the Zoom to our guest, Mark Ashton. Mark, just let's make sure that we can share your screen, and then Drew and I will be muted and off video so that we can focus on the rest of our panelists. Go ahead, Mark.
Okay, well, thank you very much, everybody. And it's nice at least seeing you all, if not in person, remotely. So what I'm going to talk about today is I'm going to talk primarily about my experiences in our work in southern New England. And in particular, I'm going to be talking about their disturbance history, particularly the most recent disturbance history of the forests in southern New England. And secondly, what to do about some of the impacts that our forests are having on in that region in the last 50 years. Primarily, how do we go about developing strategic adaptation and resilience impacts? And I will touch on a little bit about some of the secondary management strategies that we talk about in terms of mitigation and climate change, but I'll only touch on that. So the first thing you should recognize is that you might not think about this, but 14,000 years ago, we were under a mile of ice in southern New England. New Jersey was severely impacted. It was sort of taiga. And what one needs to think about is that our forests, the first thing that you can think about, are extremely dynamic. 14,000 years ago in terms of generations and in terms of how forests have changed from being under ice with nothing and bare soil to ones which are now fully structured and multi-species and diverse. That's not very long. And they have changed over time in relation to changing climate. Not only that, they have been changing in relation to disturbance. Disturbance, particularly episodic, strong disturbances that are exposed, but particularly in terms of New Jersey, but also in southern New England, to hurricanes, tornadoes, all kinds of windstorms, strongly forming and regenerating and recycling the dynamism that our forests face. And on top of that, ever since glaciation, people have been on this landscape, and people have been facilitating this kind of landscape and working with that disturbance dynamic and actually accentuating that disturbance dynamic, particularly through Native Americans for 14,000 years, or for at least in the ancient past. And that's through swidden agriculture and cultivation and through fire. And that's promoted what you see here in my example. I'll be focusing primarily on southern New England, but it's not far from the New Jersey Highlands. It's the same forest type. That yellow is really an effect from both natural disturbances, the climate, the hurricanes, the tornadoes, and people. Oak, hickory forest types. People, and as you see in the bottom center diagram, people and Native American population densities in relation to the impact that those people had on forming and facilitating forests that were conducive already to those kinds of disturbances in the climate post-glacial. And this is an accentuated example of this, particularly in terms of what you see in terms of the distribution of oaks and hickories as compared to northern New England. Very much one formed by and facilitated by people. And they are foundation species. They're what not only people were dependent upon in terms of hunting and fishing and nut gathering and cultivation, but is what a wildlife were dependent upon. So what do we see today? Today, in the last 50 years, these forests have been largely impacted by a whole host of more recent legacies. The most important one, of course, is colonization by New Englanders, by Europeans. And the legacy of that colonization has had a huge impact on creating an even-aged, relatively simple, maturing forest today, about 80 to 120 years. Okay, and superimposed upon that is forest fragmentation. Fragmentation that has gone on for the last 30 years in terms of between 0.5 to 1% a year of road building and houses and parcelization. This is what you see in southern New England, but it's also what you see in New Jersey. And that is what we call as the permanent edge effect. These are lands in which have been permanently impacted by edge. Roads don't go and come. Disturbances do. Forests regenerate after disturbances. Those are not permanent edge effects. Houses, roads, infrastructure is. And that has really provided an avenue for all sorts of exotic insects and diseases beyond the control of what has been historically faced to these forests. They're all introduced through trade. And as you can see in this map, the concentration of exotic insects, as well as diseases, as well as horticultural introduced plants, is in the Northeast. It's had a huge impact, and it's been facilitated by all this edge, this parcelization, this fragmentation. And not only that, we have pollutant loading in not too recent past. This is a map of ozone showing the impact of ozone as a pollutant on the coastal Northeast, but we have nitrous oxides from pollutants from vehicles. We have heavy particulates from power stations. We have road salt. All this also compounds and facilitates the edge effect that our forests are now, an even-aged forest as a legacy of land abandonment, are now facing, a maturing forest. And lastly, on top of that, we're worried about the more rapid changes of climate because of our own impacts on climate change through climate warming. And that's really impacted our climate in a number of ways. This is taken from a sort of summary set of long-term ecological studies done at the Harvard Forest and done in New Hampshire at the Hubbard Brook Forest, long-term ecological sites, which have been monitoring these impacts, in which we have much stronger droughts during the summer, but superimposed upon that, much stronger, more accentuated short interval rainstorms, much more moderated winters with reduced snowpack, higher flooding, higher erosion, a frozen ground, and therefore stronger abilities to decompose and lose nutrients. So all these are actually interacting and impacting the nature of our forests. It's not just climate change. Climate change is compounding all these issues, such that we have, beyond what we do within the forest itself, all these compounding influences that relate to, as you can see in the top left, defoliation from insects. This is the massive defoliation outbreak from gypsy moth that you see in southern New England just a few years ago. The emerald ash borer, which is basically essentially liquidating and taking out all our ash from our riparian forests. Fragmentation, what you see in the bottom left-hand corner from parcelization in the built environment. And of course, climate change itself and accentuated stresses such as drought. So it's a no-brainer from my perspective as a scientist that the first thing one needs to think about are the primary strategies of trying to ensure that these forests can adapt to all these aspects and are more resilient for the future, irrespective of their abilities to mitigate carbon and mitigate climate change. The first thing is they're not going to mitigate climate and mitigate carbon and absolve the sort of impacts of climate change if they are not healthy forests. So the primary thing to think about is managing for adaptation and resilience. And this is what I'm going to talk about just for the remaining parts of this lecture. And the first thing is, beyond the control of any forester or conservation organization, is one needs to stop fragmentation, stop land conversion of forests to houses, forests to roads. There needs to be strong laws about that, because it's the fragmentation is the entryway, the edge effect that is really facilitating all these exotic insects, diseases, pests, irrespective of the management strategy you might take. One needs a very strong monitoring and detection program across the state in order to detect any kinds of incipient changes that we can take action about, that we can understand, that we can delve in further, and control factors, controlling non-native plants, insects, and diseases when and where appropriate within our forests. And we need to institute laws, policies, inspections, and controls around importation and around controlling insects and diseases in particular, and around controlling and land use planning around development. And lastly, we need to have much better methods and modes of education and informing both the public and landowners about these issues. What can we do within the forest as compared to outside? We need to develop an adaptation and resilience strategy that is risk averse. It's like the stock market. We don't know exactly what's going to happen. because of all these compounding factors. Makes things very difficult to predict. So we need to invest in a whole host of strategies, a risk-averse approach, an inclusive management approach, not exclusive. We need to be dynamic about this. We need to manage for diversity. Everybody or every species that we can think of that are part of the system, part of the ecosystem, need to be represented in different in terms of species, age classes, and successional stages. We need both active and passive management approaches that are dynamic in space and time. Our forests are dynamic in space and time. They're not static, they're ever changing. And we need to recognize this in a very different, perhaps, time scale from what we observe. We need to manage with disturbance in mind, particularly in terms of episodic, and we need to maintain the integrity of the stand dynamic, the stand regeneration cycle. Yes, disturbance is part of our forest, and yes, if we do it right, disturbance will allow for regeneration and allow for the progression back into later successional stages and then come back into full cycle. So what do we need to think about in terms of resilience? We know with climate change and increasing mean annual temperature and precipitation, gross primary productivity and net primary productivity obviously increase with warmer, more abundant rain. But we don't have just warmer and more abundant rain. It is much more seasonal. It comes and goes. We have strong droughts, and compounded with strong droughts, we have warmer temperatures that is going to increase respiration, the body maintenance in terms of the superheating of living beings is going to increase respiration of those ecosystems. It's going to increase decomposition, and it's going to increase with droughts stresses like defoliation, like hotter, drier environments, more exposed environments that trees may or may not adjust to. We do not know. And so there are very strong possibilities that mature and maturing forests do not necessarily increase in carbon sequestration. They may well decline in net primary productivity. They may essentially decline to a new, essentially maximum of capacity in terms of carbon sequestration. And we need to essentially manage for this or understand those circumstances. So finishing up in terms of our understanding here, we need to think about our science in stand dynamics. Forests are regenerated in our environment episodically and strongly through what's called initial floristics, i.e. hurricanes, windstorms, and we need to cater to that regeneration dynamic by, they're going to be there, but with an even-aged maturing forest, we need to essentially move that forest and that dynamic. We need to manage for that dynamic actively to something which is essentially creating all sorts of dynamic, changing structures that is going to diversify the possibilities across the landscape for different levels of diversity, structural diversity, age class diversity, species diversity. And that means, and we've got a lot of these studies that have shown and demonstrated this, that by playing across landscapes and within stands, within treatments, within sort of populations of trees, we can dramatically increase diversities of herbs, trees, birds, amphibians, reptiles. And from our own forest studies at the Yale Myers Forest in southern New England, we've shown that there's a much greater increase in diversity of birds, reptiles, herbaceous plants as compared to the surrounding forest land when we take a more active, inclusive, strategic set of treatments to manage for that diversity. And it's much greater in levels of significance to essentially a more passive one. It's not to say that we don't practice passive, we should, meaning reserves, but they should be embedded within an active management strategy. The other aspect, and the last aspect I want to touch on, is the fact that if we are trying to manage for stable carbon that might be at new lows within our forest and within our stand dynamics paradigm that is continuously moving, okay, dynamic, We need to essentially lower the excess carbon that is unstable. That's going on very visibly in the Western United States, where fire is essentially liquidating whole forests to zero. Whereas if we'd introduced fire instead of fire suppression to a lower maximum, we would have essentially had both a mitigation ability and an ability to sequester carbon from the excess that we would have taken out from potentially what we define as low or restoration thinnings, reintroducing fire back into those systems, and then essentially sequestered it in more stable forms, long-lived wood products and wood products that essentially can substitute in a much more energy efficient way and therefore save. This is another mitigation strategy from cement and steel. Wood products are now creating a built environment, new kinds of wood products. So I have really shown you that resilient strategies can lead to mitigation strategies and that they can be useful in terms of longer lived wood products and substitutions. What I haven't talked about is what we know about soil and forest carbon, the science of this, and what we can do on the other side of active management, which is maximizing sequestration. But maximizing sequestration through reserves also comes with greater risk and potentially higher loss. We have to do both. I'm going to stop there, and I'll let my colleagues take over. Thank you very much.
Thank you, Mark. We'll turn it over now to Dr. Durant.
Okay, thanks. This is really an awesome opportunity here to talk about biodiversity and forest, and I'm very excited to share with you a little bit of that today. So I want to start off by saying there is a certain type of image that the public seems to have. And if you do Google searches of the word forest or even nature, you're going to get a lot of images that look like this one here, where you see large, tall trees, big stems, really wide, and they're going to be spaced apart. There's going to be a lot of shade. And this is a forest, and this is a beautiful forest, and this is certainly an important type of forest without a doubt. But this is not the only type of forest. And I want to follow up from some of the things that Mark just talked about managing for all of the different types of species in a particular ecosystem and thinking about that sort of important dynamic. So this too, here, this is a forest. This is also a forest. This may not be what most people think of when they think of forest, but actually this young forest is significantly more important ecologically and from even a human ecosystem services perspective than I believe the general public is aware of. And so I would like to talk about that a little bit here. So this really all comes down to understanding a very important fundamental concept in ecology, which many people in this seminar may actually be already aware of, but I'm just going to do a very brief overview. And this is the concept of succession. And that is simply the replacement of one ecological community by another one over time. And so basically, when we say ecological community, we're talking about all of the species that live in an area at a given time and place, right? And so perhaps you have some sort of a disturbance, whether it be fire, whether it be selective logging, whether it be a windstorm, whatever it is, it may take a specific area and remove a lot of that biomass, a lot of that material, the standing trees, the herbaceous plants. And then from that disturbance, there will be a regeneration of species coming in, either things that were already present in the seed bank or other species that were able to colonize quickly and get into that area. And so you start out with a community of things that include a lot of annual plants, grasses. These are things that are not going to persist for very long. They're going to be there for a year or two, and then they're going to get replaced by species that are better competitors. And this is going to happen over time. And we're going to see some of these grasses and perennials taking over, and they themselves will be eventually replaced by shrubs, young trees, and this is going to change and change. And eventually you're going to get to a forest. This might be 150 years later, but you're going to get to a forest that is going to no longer change in its species composition, and we can call this a climax community. And so this is a natural process and a fundamentally important process for biodiversity, and this is something that is unfortunately not factored in as heavily when people make conservation decisions, in my experience. I think this is a critically important concept here. So I want to also point out that we were talking about the plant community, and the plant community dictates the animal community. So the birds and the mammals, the insects, other things are going to follow the changes in the community over time through succession. And what we really see is, when we come right down to it, there's this idea of conserving the deep, dark forest, and that's super important. And there are great areas of mature climax forest, but we're only talking about the end product of this long successional pattern here. And so what about the entire rest of this, right? There's a lot that's going on here, and I think that is being neglected to a certain degree. And an important point here that is very poorly understood by the general public is that biodiversity is not evenly distributed throughout time and throughout successional stages. This is a critical point here. This has been shown over and over and over and over again in many different studies. Here's a graph from the classic study by Whitaker in 1970, looking at forest regeneration. And what you see is, after a disturbance, there was an incredible increase in the total number of species present in a community, which we can also refer to as species richness. And this goes up, and it goes up actually very quickly, and then it plateaus, and then it goes down. And while this is happening, the biomass, which is the total material, all of the wood, all of the leaves, all of the fungi, all of those things that are building up, does increase over time, but the species richness actually declines. And again, this is extremely well established both experimentally and empirically. And what we see is, when you map this onto the different successional stages, really it comes down to where you have an old field or a young forest is going to be the highest diversity that you're ever going to see in an ecological successional pattern here. This is going to be where it's going to maximize, and then it will decline. And to be very clear, there's different species at these different stages, and some of these will only be found in the beginning, some will only be found at the end, and some will only be found in the middle. And so it's an important point to think, well, we really need to be managing more than maybe we have for some of these earlier successional stages, all of the stages being important, right? This is not something where we should only manage for old fields or only manage for old growth forests. We need to have all of these things together. But an important point too is that actually the benefit of young successional stages is very great, and even great for things that are classic late successional species, things that live in the deep dark forests. We actually find that things like bobcats, for example, they prefer to forage for food the closer you get to a disturbed edge. In this particular study that came out last year, they showed areas that were managed with ecological forestry that was done to maximize the biodiversity in an area. They actually preferred to hunt near those places, which is not surprising at all to anyone who studied bobcats, but it was still demonstrated. And this has been shown with birds as well. So many birds, as Mark just talked about it a minute ago, this has been shown in all different kinds of organisms. This is not exclusive to bobcats or any particular butterfly or anything like that. This has been shown over and over again for different organisms. And so here we see there's a study of birds, and they looked at 9 different birds that are associated with mature forest. And what they found was, post-fledgling, when they're out hunting, they actually prefer, in most cases here, 7 out of 9 species actually preferred to forage in wildlife natural openings or areas that had been managed with forestry. And they were found significantly higher amount of the time in those areas than in the deep dark forest. And so this was shown again, another species here, red-eyed vireo. And so I think this is a really important point. But not only can we say that the majority of biodiversity resides in these early successional and ecotone, which are edge habitats, areas where you do have an interface between different successional stages. What about the rare and endangered species, things which are the most vulnerable to extinction? Well, when you look at that, and you could take any particular group, whether it be insects or plants or birds, this is shown over and over again, that the rarest of the rare are almost always found in these early successional or ecotone habitats. Here's just a sliding window of one particular page of endangered plants and plant species of concern in New Jersey, and the vast majority of them are not going to be species that are found in the interior forest, or actually things that are found in early successional forest or old fields or ecotones between different types of habitats. Now, one thing that's really important to note is, when we think about historical perspective, what what did it used to look like? We heard about what was going on 14,000 years ago. And so what about like even more recent times here, like in the early 1900s, up to 60% of northeastern forests were shrublands and young forest. And what is that today? How much of New Jersey's forest is currently shrublands and young forest? We could say under 20 years old. It's about 3%. So this is a dramatic reduction, and 3% is not a healthy number. This is not a healthy number by anybody's estimate. And so we've lost a number of species, and a number of species are rare in our New Jersey forest. And so we can see things like the golden winged warbler are in trouble in a number of areas because of this loss of young forest. You know, having areas that include habitats like this is going to really promote the survival of species like that. But I want to be abundantly clear. We're not talking about one species like the golden winged warbler. We're talking about hundreds or thousands of species that all live in these same exact areas and all benefit from early successional habitats and management. So I think this is a really, really important point, that this is not a single species. This is the majority of biodiversity, as we've shown here. And I want to be very clear too, when we're talking about things, Mark mentioned land conversion. And so this would be an example of land conversion where an area was deforested and turned into, this is about to become an oil palm plantation. This is not at all what we are talking about here. We are talking about forest management where forests are allowed to regenerate. They do not turn into shopping malls. They do not turn into oil palm plantations, right? And so that is the focus of a lot of the things that we're going to hear about today, is this forest management, which can be, as we've already shown, as Mark showed and I've shown, ecologically sustainable by actually maximizing your biodiversity. So that's what I have to say to you today.
All right, thank you so much, Dr. Duran. We will segue now for Dr. Olson.
Just give me one moment here, just getting stuff ready. Okay, so everybody should be seeing my presentation here. Of course, I don't have it on the correct slide. My apologies. Okay. So again, my name is Matt Olson. I'm with Stockton University. And today I just want to share with you some of my thoughts about forest health, but from a Pine Barrens perspective. Seems like a lot of the discussion's been focusing kind of more on what's relevant, say, to the Highlands, although I'd say all this is relevant even to the Pine Barrens, but it's been a little bit more Highlands focused. But I want to kind of bring a little bit more of a Pine Barrens perspective into this. And I'm really appreciative of having both Dr. Ashton and Dr. Duran going ahead of me, because they really laid a lot of the foundation or the groundwork for what I'm about to talk about. So I'm not going to talk too much about kind of the habitat aspect specifically, or succession or anything like that. I'm just going to focus a little bit more on what I see as being kind of some of the threats facing the Pine Barrens, and then also kind of like some paths forward. And so, when we think about forest health, we have to have a definition of what constitutes a healthy forest. And so I'm going to take more of a systems view. That way it's something that can apply to different forest types and in different situations, and not even just the forests. I mean, this would also apply to other ecological systems. But so I'm going to just kind of think of it in terms of a healthy forest as something that is resistant, resilient, and responsive to environmental changes. So that'd be changes in climate, disturbance regime changes, whatever that might be. It's just that these are systems that are kind of geared up to be able to withstand, to rebound, and then perhaps transition to a more desired state in the future, kind of that adaptive capacity idea. So for me, that's kind of inherent in a healthy forest. It's one that's going to be able to persist in some form or another, structure, composition-wise, into the future in the face of disturbance events in a changing environment. So that's how I'm going to approach it from that perspective. For today's talk, talking specifically about the Pine Barrens, I'm going to focus a little bit more on the first two pieces, the resistance and the resilience. I'm not going to speak too much about adaptive capacity, because that's something that could very easily take another webinar to really delve into in detail and to do it justice. And so, if we're going to talk about the Pine Barrens, we have to have some kind of context. And I think most folks recognize the historical importance of fire in the Pine Barrens. It's just, it's pretty obvious in the species composition that we have. We have, a landscape that's largely dominated by one species, pitch pine, which is both resistant and resilient to fire, very fire adapted species. Some might even say that it's fire dependent in many ways, particularly for long-term persistence, of course, just depending on the ecosystem. But we also have shortleaf pine and a variety of oak species that also exhibit levels of resistance and resilience to fire, repeated fire, regular fire. So just kind of looking at the present forest and also some other previous historical evidence, we know that our Pine Barrens forest was impacted by fire for thousands of years. I mean, going well prior to European arrival, for upwards of 10,000 years, if not a little bit longer. And we have evidence of this in the microfossil pollen record. So it's not just in the species composition based on the pollen record, but then also we have charcoal in the pollen record that tells us that fire was a regular part of the life of the Pine Barrens forests. So certainly something that was very important historically. I think something interesting as well, just kind of focusing on the composition that some of this historical evidence suggests, is that we had basically a pine-dominated condition for thousands of years, and then also fire occurring for thousands of years. So that tells you something about the resilience of the Pine Barrens forest, that in the face of that disturbance, it helped to maintain it, but it also helped to maintain a particular condition over time, one that was pine-dominated. So I think our Pine Barrens forests are just inherently resilient. And then, of course, the proof, too, is the fact that we still have a pine-dominated forest today, to this point. The Pine Barrens have gone through repeated cutting, and this is a place that, to call it a second growth forest, it's more like fourth, fifth, maybe even sixth growth forest in some places because it's been so repeatedly cut and utilized. But what do we still have? We still have a pine-dominated forest. Now, it may not be the forest that existed in the past. In fact, it most likely doesn't really resemble it too much other than the species composition. But I think it's important to keep in mind that the Pine Barrens are a very resilient forest. And I think some of that resilience is based on the fact that the Pine Barrens forest historically had a particular structure and composition that allowed it to persist in the face of changes that took place, climate changes that took place over thousands of years. And one of the things that helped to maintain that was regular disturbance, in particular fire. And so one thing I also want to talk about a little bit, and I need to introduce some concepts here, is this idea of a forest versus a woodland. Increasingly, ecologists are starting to recognize that it isn't just a forest, a savanna, or a grassland, depending on your density of trees. But there's kind of this gray area between a forest, which is heavily tree dominated, and a savanna, which is just kind of sparsely treed. There's this kind of gray area that they're recognizing now and calling a woodland. So categorically, it's its own ecosystem type now. More and more folks are recognizing that. And just one of the main differences really between, say, a forest and a woodland, we want to draw that distinction here, is that woodlands would be more open canopied. They'd have fewer trees. And in particular, you'd have less of a dense mid-story and understory of woody plants. So it'd be very park-like. You'd see pretty far throughout the forest understory in a very gappy kind of canopy condition. And then, of course, there's also ground layer differences and all of that. Well, one of the big factors kind of pushing either the system in the direction of a forest or a woodland has to do with repeated fire. So fire, particularly relatively frequent fire, favors more of a woodland condition over something like more of a forest condition. You pull fire out of certain systems, they densify, they become more of a forest. Right. So the idea is that fire suppression is perhaps left us with more forest than what we had historically in some conditions, some places. So let's just kind of work within that context of a woodland, because that's kind of what I'm going to be speaking a little bit more about. And so this has also given rise to the idea that woodlands were much more common prior to European arrival. This idea of the primordial forest that extended from basically the East Coast all the way to the Mississippi River and beyond, to the grasslands. That it was just this dense, multi-layered forest, very shady, that kind of condition. That idea has been largely debunked in a lot of areas, and that's just based on various forms of evidence to suggest that perhaps what we really were with the early Europeans arriving here, what they probably were met with was more of a woodland condition, something that was largely created by humans. This would have been largely through Native American, first American burning and such, and use of fire in the landscape to manage the landscape to make it desirable for their own purposes. So certainly they kind of developed the fire science well before we did. In fact, I still think we're trying to play catch up in a lot of ways. Okay, so then the question is, what does a healthy Pine Barrens forest look like? Well, first I would argue that perhaps we can't really think of it in terms of a forest. We have to think maybe historically we had more of a woodland condition that was resilient, that supported the biodiversity that we know of in the Pine Barrens. But so maybe it's best to think about a healthy Pine Barrens woodland rather than a forested landscape. And so what I think of more as kind of a healthy condition for the Pine Barrens would be patches of regenerating forest embedded within a matrix of woodland, kind of at the larger landscape scale. Of course, I'm just focusing mainly on the uplands, being our dominant forest type in the pine barrens, not so much touching on our forested wetlands and stuff like that. And then I would also make the argument that this kind of condition would be both resistant and resilient to things like wildfire and other forest health threats. Dr. Ashton talked a little bit about the benefits of thinning, in the sense that we're reducing stand density, we're concentrating resources on fewer trees. Trees are less stressed, all that kind of thing. So trees that are less stressed are going to be ones that are going to be better positioned to be able to withstand things like drought and insect infestation and things like that. So my thought here is that a woodland dominated landscape is one that would, number one, wouldn't promote the propagation of large wildfires, would help to keep the fires a little more manageable for us, which clearly is a health concern. I don't think anybody would argue that. And then also it would also benefit the forest in that the trees would be better positioned to be able to survive through the really stresses associated with extreme drought and such. Again, Dr. Ashton kind of pointed this out really well, I think, with some of the projections suggesting that we're going to get these really heavy rains punctuated by long periods without rain. And that's not necessarily good for our forest or for our natural systems either. So I think this type of a woodland landscape would be something that would be a little more compatible with resilience in our forests, improving the health of the forests, and perhaps also with the adaptive capacity of our forests, helping to kind of boost that a bit. Of course, it's not just the structure of the landscape, but it's also the composition. So in our pitch pine and our shortleaf pine, particularly our pitch pine, which is the dominant for the most part, we also have quite a bit of shortleaf. Both of those species are actually projected to do fairly well under future climate. So there's plenty of evidence from various sources to suggest that those species may actually be pretty well positioned. And so again, our pine barrens forests, maybe a healthy forest in the future would be something where we do have quite a bit of pitch, maybe try to push our composition a little bit more to shortleaf, which is actually projected to do like fairly well into the future, being where we're basically at the very northern edge of that species range. As conditions get warmer, that species presumably is only going to do a little bit better. It's actually going to give that species a bit of an advantage. That maybe even trying to increase the amount of shortleaf relative to pitch pine may be a good direction to go in. And so, I can't not take the opportunity to put in a little bit of put a plug in, I should say, for some of the work that we're doing at Stockton University. And so, I'm working with my students on a lot of different things, and working with our forester, Bob Williams, who's our consulting forester, seems to be the consulting forester for much of New Jersey. He's been implementing ecological forestry on our land at Stockton. And this includes what I consider to be woodland management. So he's doing combinations of thinning. They've been doing free thinning out there. So there's been a few examples of this over the last, say, 5-10 years. And then also with repeated burning. So it's kind of creating this kind of woodland condition. Now we still need to go out and start really trying to assess and drill down into the resilience of that system. But there is evidence to suggest that this is going to be something that's good for our land base. Again, I just want to put in a plug for Stockton here. And so here, just to kind of show you some of the progression here. So what you see on the left, this is a crowded, very dense pine forest. This is actually close to the Garden State Parkway, something that I'm sure would show up as red in any type of wildfire vulnerability model. Something that just clearly is not a condition that's very healthy, and it's something that we do not want on our property. But then contrast that to what you see on the right. And what you see on the right there is more that managed woodland condition, where trees have room to grow, and where we're using regular fire to mitigate potential wildfire effects by reducing fuel loads and things like that, and also just benefiting our pine barrens ecosystem with a species adapted to that regular fire regime. I also want to talk just a little bit about active and passive management. I think folks gave talks beforehand, really hit this much better than what I'm going to do here, but I just want to kind of reiterate here that these two approaches to management are not mutually exclusive. They really are not. It just depends on the scale in which you're considering. And I'll just take an example from my time in Missouri. I used to work for the Missouri Department of Conservation, and there they routinely integrate this idea of ecological reserves into their management compartments. And usually they're setting aside about 10% of their management compartment in ecological reserve for the purposes of benefiting biodiversity, to ensure that no matter what, there's going to be some of that mature forest habitat that's just going to be mature forest, and it's just going to, it's going to be dynamic on its own with minimal human influence. And so I just want to kind of reiterate the importance that these things, it isn't one or the other, but the two can really work in harmony. And foresters and wildlife biologists and ecologists have recognized this for a long time. And then finally, I also just want to kind of touch on this idea of climate adaptation and mitigation. And again, Dr. Ashton did really well, I think, in kind of framing this idea here. But I just also want to kind of point out one other thing with this idea of adaptation and mitigation is that the two themselves, they also are not necessarily mutually exclusive. Now, where they are mutually exclusive is in the sense that you can't maximize one and also maximize the other. But it's really an optimization issue, and you can achieve kind of an optimal level of both in the sense that, you know, say with woodland management, right? Because you're maintaining a mature forest structure in your woodlands, but it's not fully, you don't have full stocking in your stand. So you're not maximizing the amount of carbon within your stand. You're maintaining some mature forest cover. You are maintaining higher levels of carbon in your stand, but just not at the maximum. But at the same time, you're also adapting that forest to deal with forest health threats by maintaining those lower densities and those lower stockings. So to me, there's kind of a happy medium between those two that can be achieved. It's not one or the other. And I, you know, of course, I just threw here the production possibilities curve in economics. I don't mean to freak anybody out with economic models here toward the end of my talk, but to me, that just immediately came to mind that there is some optimization, and it's a matter of us figuring out kind of what's appropriate, societally appropriate, as far as what's an optimal point. Okay, so with that, I just want to thank you for your time, and I just left my email address here in the event that you want to contact me. So thank you.
Great. Thank you, Dr. Olson. That was really good, really interesting. And now we'll move on to our final speaker for today's webinar, Dr. Lathrop.
Okay, so it's my privilege to be cleanup batter, and let me start my slides. Okay, so I wanted to talk today about a project that we've been working on for a number of years, what we call NJ Forest Adapt. And so as New Jersey communities have been thinking about state government, local communities, county, nonprofits, and what can they do to help make our communities as well as our forests more resilient, okay? And so we've been thinking about how different kinds of tools and toolkits and information to aid that, that effort. And as pointed out earlier, you know, we know the climate is changing. There's at some level, some things are more uncertain. You know, we know in terms of increased precipitation and more frequent high intensity storms in terms of increasing the level of disturbance. And I'll also talk a little bit about, you know, in terms of rising seas. So with that as background, at Rutgers, we've been developing what we call this suite of online tools called NJ Adapt. And one of those that we've been working on is NJ Forest Adapt. And our goal here was to enable users to visualize data over multiple timelines, think about different climate change scenarios, and to put that climate change information in terms of what was more relevant in terms of forests, as well as what is the state of our forest right now, and to provide greater context, to show some of the other stressors that that Mark talked about, but also Dan and Matt. And so our goal, again, is to promote healthy, climate resilient forests across New Jersey, but also the broader US. And so in terms of this primary objective is to develop a web-based GIS tool to provide place-based information on the state of New Jersey's forests. And we're basically relying on data from a diversity of credible and authoritative sources, and to provide ready access to this information, again, to government agencies, nonprofits, individual landowners. So the tool itself, NJ Forest Adapt, is broken out into different themes. Again, there's a climate focus and climate associated risks, but also other information about the state of the forest today in New Jersey, a little bit about potential future change, and just some of the other disturbance risks that are out there. So for example, again, this is showing just the amount of forest cover in New Jersey, but we're calling it NJ Forest Adapt, but in most cases, we're taking a much broader lens in terms of the mid-Atlantic or the entire Northeast, depending on the availability of the data. Some cases we drill down more closely into the state itself. In this case, looking at different types of forests, where they are. You can see, the Pinelands stand out there. That was just a discussion by Matt, and then some of the earlier discussion on our northern New Jersey forests, which are showing up more in terms of red. And then information about forest carbon in terms of the existing, what we know about the existing stocks of forest carbon. In terms of the tool itself, we provide, there's this little I button that shows, where the source of information is. So if you want to go to the original source. And a good part of it is in terms of related to climate. And so this is working with downscaled global climate models. So it's a broad brush. We have to recognize that these climate models, you can only drill down so far in terms of, these are projections. And so we provide projections out to basically 2100. You can also look at historical baselines as well as the change between baseline and in terms of the future for a number of different parameters. And so as part of the tool itself, we try to provide various kinds of tips in terms of how you could use this information for decision making. So in this case, this is looking at, more from an urban forest perspective, how you might look at, in this case, insect and disease issues. So for an example, in this case, growing degree days. And so trying to take the climate data and actually using climate parameters that actually relate in terms of forest health. And again, you can look at historical, you can look at future. Again, there's uncertainties. So we have a couple different scenarios. You can look at change versus baseline. But the bottom line in terms of growing degree days, New Jersey is going to look more like the Carolinas in terms of the overall means in terms of climate. What the climate models are weaker on are some of the extremes, in terms of the intensity of precipitation, actually being able to model that, or the duration of droughts and the like. As part of the tool, we incorporate information from a kind of a plant-centric approach, things like growing degree days. We also incorporate information about heat zones. And so heat zones is another parameter that basically looks at how extreme the heat will be during the summertime. And that affects in the long term in terms of the competitive fitness of different species in the landscape. And it also, basically some species may not be able to tolerate heat as well as other species. And so, again, that would affect their competitive fitness through time. And so the U.S. Forest Service has developed a climate change atlas. And in this case, they're looking at the climate niche for a particular species and how that might change with climate change. So here, we, as part of the tool, we've incorporated a number of important New Jersey tree species. In this case, we've got eastern hemlock. This is showing its kind of percent importance value in terms of the basal area, the amount within a particular forest stand. So under the present day, and you can just see, this is a species that finds its southern extent in northern New Jersey. And then in terms of looking into the future, we can see that basically it's kind of expected to move further north. And then you can look at the predicted change. There's other species that we expect to become more important in our forests. This is showing loblolly pine under the current baseline and then under future scenarios. So that may be a species that would move into our pineland system. So again, we have the Forest Service and other groups thinking about what species might likely decrease, others that might increase through time. And so again, you can think of these in terms of, potential winners versus potential losers. And this becomes important if you're actually going to be investing in terms of planting trees or the like, okay? In an urban forest or potentially in rural forests, again, trees, you got to plan out a century. And so thinking about how climate change might affect that forest. And so we try to provide information, links to tools here to help you in those kinds of decisions. And then information about risks. In this case, Mark talked about, in terms of the emerald ash borer, where our ash are vulnerable to these particular risks. In this case, down in the Pinelands, southern pine beetle. So a number of different risks to our existing forests. What we don't know yet is, how climate change will, be able to estimate some of those future risks, less certain. Matt talked about wildfire hazard and the variation of that across the landscape in the Pinelands. And then something that we haven't talked about is our coastal forests. Those forests that are adjacent to our salt marsh are also vulnerable to change, in this case due to rising sea levels. And so this shows which areas might be more vulnerable to that over the coming century. And then finally, as part of the tools, we incorporate, again, links to various resources. We bring this down to the municipal level. So we created a whole series of municipal forest snapshots. So if you want information about this present state of your forest, we have this for every municipality across the state that's already been put together. If you want to share maps from the tool, you have ways to do that. And so NJ Forest Adapt is continuing to grow and evolve as we get input from various end users. And so we welcome your feedback. And this has been a big team at Rutgers, as well as we have a number of different outside collaborators at the state level, as well as the federal level. So I'll close with that. And I guess we segue into discussion.
Yes, thank you so much. That was really interesting. So now we're going to move it over to Drew Tompkins, who is our policy director at New Jersey Audubon, and he is going through the Q&A, and take it away, Drew.
Hi, everybody. Thank you so much. And I see that Professor Ashton has already started answering a few, but I think it'd be great for everybody, for people who aren't looking at the Q&A, to also hear some of these answers and also open it up to other panelists as well. And so the first one I want to flag is, given the expectation of additional disturbances due to climate change, why would we need to have other current forest management disturbances, human-made forest management disturbances, such as thinning of trees, et cetera, if we're expecting more disturbances to happen naturally?
So do you want me to answer that orally, or do you want somebody else to answer that?
If you want to jump in and answer it orally, and then if anybody else.
So the logic here is you're trying to mitigate against some of those disturbances, right? Climate change is going to accentuate and create more severe, particularly wind disturbances, but also drought. And this is going to also facilitate probably positive other stresses like insects and disease. And if you're trying to get on top of that by creating newer, younger disturbances as a part of mosaic to break up the age class, to create greater structural diversity and species composition, before the chronic continuous sequence of much larger catastrophic disturbances, you're making that forest more resilient to those disturbances, and therefore withstanding some of those disturbances before they become too catastrophic. Sort of what has been proposed and has been failed to be done out west, where through even-aged heavy cutting and through climate change compounding a maturing forest from that heavy cutting, and fire suppression, all those forests are way overstocked. If one had introduced a lot of what's called low thinning and reintroduced fire that Native Americans had perpetuated to withstand lower maximum carbon, you would have much greater resilience to those forests to catastrophic fire with climate change.
Does anybody else want to add anything in there?
Yeah, I was just going to jump quickly in, just kind of following up on what Mark was saying. And I think also like kind of keeping the tools in the silvicultural toolbox, allowing us to implement silviculture where and when we think it's appropriate, we can actually affect the species composition to something that is more desirable. You know, we can use silviculture and deliberate disturbances, interventions into stands to regenerate the species that we do feel, you know, based on the science, are going to be better adapted to the future. So we can help transition our forests to that more resistant, resilient state. So I think it's important that we keep that in mind too, because the way our forests are structured now, if these disturbances happen, it may not result in the kind of regeneration that's going to leave us with a resilient forest. In fact, with things like deer and invasive species, plant species and stuff out competing some of our natives, we may actually go from a forest to something else in some cases. So it's through that management that we can have some control over that regeneration process to really work with the forest. By taking that active hand, we can kind of transition our forest to kind of help it along.
Great. Richard or Dan, are we good to move on to the next question? Good, excellent. So next question. I've had a couple, I think this is more for a clarifying point, and anybody feel free to jump in. Can you explain the difference between deforestation and using management techniques to create different levels of forest, different age classes of forest, and why that's not considered deforestation in the same way that some other practices would be, like roads or even agriculture? Could you just clarify that for everybody to make sure that we understand what's going on there?
Sure, I'm happy to kind of jump in here. It ends up, it's what it turns into, right? So if we take a forest and we turn it into a housing development, there's no ecological succession that's allowed to happen there. You're not going to get wildflowers. You're not going to get certain species of butterflies and grasshoppers. They can't come in because the real estate is taken up by a new type of land cover. Whereas in the case of managing forests, and especially in an ecologically sound forest management plan, you would have, succession would be allowed to occur. Basically, that's it. It's whether or not you allow succession to occur or not. And when you allow succession to occur, again, as we showed, as Dr. Ashton showed, and as I showed, this is going to actually maximize your species diversity across the board, with the vast majority of species are going to have. Whereas, again, if it turns into agricultural field or a strip mall, that's not going to happen at all. There's no possibility for that because that real estate is taken up.
I can add to that. You know, the kinds of disturbances that we create through silviculture and through forestry should be simulating those kinds of disturbances that those forest types have co-evolved with. That's really important. If they've co-evolved, they have immediate adaptations to recolonize, or they're present on the ground itself. And so they essentially have an incredible ability to succeed and follow successional trajectories again. But many disturbances, such as roads or mowing fields or agriculture, or permanent openings in which you're creating disturbances that have not co-evolved with those disturbances, are extremely susceptible to exotic insects, diseases, plants, invasives that are adapted to those. The reason why they're adapted, they're often found in those kinds of disturbed areas, is because they have those kinds of traits from other ecosystems that they have co-evolved with that make them uniquely adapted to the kinds of conversion or deforestation aspects that our native plants are not evolved with. So there's dramatic basic differences in this that one needs to understand, okay? Chronic maladapted kinds of disturbance regimes, bad. And that's what I mean by fragmentation. And disturbance regimes which you simulate the kinds of disturbances that have been co-evolving with these forests for thousands of years, good.
Great, thanks so much. So the next question I have is touching on something we didn't talk about too much today, but I'm sure there's plenty of detail that you guys can provide on this. Deer impacts and non-native invasive plants are major threats to the forest in the Northeast especially. That being said, does active management always mean that we're just simply, clearing trees, which we did talk about, or using fire, or are there other ways that we can go about it, and do forest management plans help develop these type of strategies for dealing with other problems our forests face?
Let me jump in on that. So I manage a 400-acre preserve for Rutgers, and one of the first things I did as part of that was developing a deer management plan. So I see deer management as part and parcel in terms of forest management, and part of that is to promote the biodiversity that a number of the other speakers have talked about in terms of the floristics, as well as the birds and the herps and the like, that when you reduce the amount of understory, you're also, in terms of the forbs, the grasses, the shrubs, as well as you're reducing the possibility for forest regeneration. And so when there is disturbance, when there is those wind disturbance, open up canopy gaps, that you don't have the native forest to be able to respond, and those as compared to some of the exotics. And so deer management needs to, it is part and parcel. And in some cases, hunting isn't going to be enough. You're going to have to be doing things like fencing, potentially planting, if you're going to want to reintroduce certain species or promote their growth. So, but it's really got to be part of the broader toolkit.
I would also make, if you can, reintroduce the top predators in parts of Connecticut now. We used to have very high deer populations, but with the slow in sort of recruitment of forest-based, and when I say forest, I mean that generally. I'm not talking about necessarily closed canopied mature forest, but forest-based animals. That would be fisher, that would be coyotes that are actually non-native but have replaced wolves, bear and bobcat. They have dramatically limited deer populations because they predate on the fawns. But if you don't have that, then you have to have a more active hunting policy, and you have to go to more stringent aspects of fencing and controlling deer if you can't have a hunting program.
And this is where the fragmentation issue gets in terms of that fragmented, where it's fragmented due to urban, suburban, using hunting as a tool becomes more difficult than it is in our more open, rural, contiguous landscapes.
All right. Next question is, will New Jersey be able to establish cedar forests further inland as it experiences sea level rise? And will this happen naturally or require human intervention? And I guess especially for Richard, is that what we should be looking for? I think that's probably directed at you.
So Atlantic white cedar occur from the coast all the way inland. Okay, so they are there. In some cases, they've been degraded. In other cases, we've got good intact white cedar forests. So it's those areas at the edge that are most vulnerable. But they are there and present, and so there is an effort to enhance, restore some of those where cedar has been degraded in the past. In some cases, deer, their red maple is a strong competitor, and so depending on the land use history, the disturbance history, could have been cedar 150 years ago. Now it's some kind of mix, whereas other ones are intact. So it's not a situation where they aren't there.
Great. The next question, I think this one's probably very specifically for Matt. There's been more attention to water budgets in relation to forest density recently, and the idea that less dense stands have more available soil moisture due to reduced transpiration. Do you think the pre-colonial, woodland conditions that occurred throughout much of the East would have been more resilient because the trees were able to have more water available and less stress? And generally, what do you think, if this is the case, or how you would describe that, what would you suggest for the forest where that's appropriate, or woodlands where that's appropriate?
Yeah, for sure. I mean, it's, the whole idea behind reducing stand density is really to concentrate growth on fewer trees, giving fewer trees, the lion's share of the resources, basically. So, and that would go for above ground and below ground. So yeah, I think there would be a situation where you would get greater groundwater recharge and stuff like that as well, right? Because more water is going to get between the root systems and make its way down into groundwater as well. So a lot of that would be able to percolate down. So not only would it improve the resilience of the forest, the trees that are there at lower density, they have more resources, more water available to them, be able to get through those stressful events, and really prevent some of those insect outbreaks, like from southern pine beetle. That might help to slow some of that by having healthier trees. But then it would also be better for groundwater recharge in addition to that. And, that can be accomplished through a variety of, just call it woodland management approaches, right? So it would be a combination perhaps of fire, and then really facilitated by thinning. So a lot of our forests have just gone unthinned, from lack of fire and stuff like that, and lack of actual mechanical removal, to the point where it's almost, I would suggest that we need to really start thinning at a larger scale to really kind of get the densities to where it is going to be more desirable, and then returning fire alongside of that kind of combination of those two things. Because one thing with fire, start putting fire into some of these stands, yes, we have some species that are resistant to fire, and pitch pine and shortleaf pine, but those really high stand densities and the high fuel loads and everything else also leaves those areas vulnerable to intense fire that can kill a lot of the canopy as well, which could lead to undesired outcomes too. So I think it's really kind of where we are now. It's going to be I would envision some combination of thinning strategically in areas like around certain communities that are more vulnerable, perhaps, to try to protect life and property, and then in combination with burning, that is, to help with further fuel reduction, and then also just more from the ecological restoration perspective, just reintroducing that important regular repeated fire into the system to get the system back to some semblance of what it was in the past.
Great. I think this is for probably everybody. I think at least a couple of you will probably have points to put in here, but do the current species, both animals and plants, in the forest now appear to be more adaptive to climate change or less? So the species we see in just general in New Jersey.
In terms of our tree species, you kind of have to look at where those species fall in terms of the gradient. So in some cases our species at the southern end, other times they're at the northern end of the range. So New Jersey kind of sits in the middle. So we probably have a decent idea about some of the plants, but some of the other animals or the insects and the like, we probably have much less information on. They just haven't been studied in the same way, but maybe some other folks, maybe Dan can talk about the insects or the like.
Yeah, I agree with what Dr. Lathrop just said. There's definitely, it's going to depend on the group. I mean, there are groups that are going to thrive. There are groups that are going to completely go away. And just the group that I work on tiger beetles. There's about 20 species in New Jersey. And I would say probably a third of them are going to decrease. At least one or two of them will be gone probably within 20 years. A few of them are going to increase, and the other ones are going to shift. And they're going to move a little bit further north, but they're going to hit walls because If you live in the Piedmont, you can't live in the high. Many of these species cannot transfer their ranges to further north places because the soil is fundamentally different. So we're going to see some that are going to get crammed in almost as if it was like another glaciation. They're going to get stuck. And whether they can persist or not is going to be, interesting thing to see. But it is absolutely idiosyncratic. It is going to depend on the group that you're looking at.
Yeah, I'd even go as far as to say too that it depends on kind of where you are. So, like in the Pine Barrens, for example, I think a lot of our plant communities, I'm going to speak from a plant community perspective, I think our plant communities are pretty resilient. But then you get to northern New Jersey where you start picking up northern hardwoods, and you're basically at the very southern end of the northern hardwood range at that point, where you have a lot of sugar maple and beech. Those are likely not going to be very resilient in the face of change. So that's probably where we're going to see a lot of change. So it's really going to depend on where you are in the state. And I think we have kind of a mixed bag here, but I would say for the most part, with the Pine Barrens being such a large portion of the forested area, I'd say quite a bit of New Jersey's forest, I think, is possibly in a pretty resilient state. It just needs a little additional assistance through active management to get it to an even more resilient state.
So
I'll have one addition to this. It's very difficult to make predictions given all these interacting factors. So that's why you want to try and manage to be as inclusive as possible, because you really don't know what you're going to get. I mean, there are some obvious sort of ideas, my colleagues here have said, but there are other sort of interactive, negative or positive feedbacks that we will not have thought about that will take place, that will provide some interesting sort of novel sort of circumstances. So I just be humble, include all.
great. And just so everybody who has put in questions, I'm trying to figure out how to formulate the last one, which is not going to be this one about climate change together, because there are quite a few climate questions that I'm sure is going to be a long and interesting answer. So I will get to that. But the next question I just want to flag is people have suggested that we should create young forest habitat on old agricultural lands or barren lands or marginal lands instead of creating habitat within our forest, young habitat. Is that a viable option? Which Professor Ashton, I saw you already answered this, but want to add other people in there and also your input here. So is that a viable option with creating it on not currently forested lands, but trying to regenerate on ag land, barren land, et cetera?
I'll jump in there. Yeah, go ahead and do it, but it's not going to necessarily, so there's a lot of advantages to doing that, but it's not necessarily going to replace the value of young forest in an existing forest landscape. And so some of the points by the other speakers is that young forest adjacent to older forests, in terms of many species rely on multiple age classes for their entire life cycle. And so just having a young forest, yes, some may benefit, but not the broader suite of the landscapes of the species within that broader community. So you have to put it in a landscape context.
Yeah, I addressed this a bit in my talk as well. I mean, if you're interested in foraging for species that live in more late successional forest, I mean, they benefit from having young forest next to it. There is no question, and there will not be the same benefit if it's exclusively transferred over to former ag. The other thing is you have other problems too, which is, wouldn't it be great if we could just put all in former ag land? That would be awesome if only it worked that way. But I mean, if you did that, you're also going to dramatically increase your invasive species too, because a lot of those areas are going to be much more prone to invasives. I mean, invasives are going to be a problem no matter where you do it. And that's just part of the reality, just like deer are problems that we deal with no matter where we deal with things. But, it's going to be even worse in areas that have had repeatedly tilled soils and all other kinds of land use changes over time. It's just, I wish if only it was as simple as just replacing one type for the other, but it doesn't work that way.
Dr. Ashton or Dr. Olson, anything else to add there?
Well, you have to have a seed source if you want to get trees back on those fields too. But I think that Dr. Lathrop and Dr. Duran have answered that pretty nice. The other thing, of course, you've got to realize is those now mature forests actually evolved from usually often the legacy of human disturbance in and of themselves. They are in and of themselves a legacy of old fields. So, yeah, whatever we do, you've got to realize that humans have been on this landscape and have been intimately part of this landscape for 14,000 years. It's only recently in the post-industrial age that we've often thought of ourselves as separate, you know, sort of the wilderness ethic. It's a very Western construct. If you talk to indigenous peoples of forests the world over, it's a foreign construct. We need to rethink our involvement within the forest. We are intimately involved with the forest. We need to make absolutely active as well as passive, but strategic, conscious decisions about being part of that forest, not being separate.
Great. So next question, much more of a just scientific, hopefully is a pretty straightforward answer that somebody can give. What is the most proper scientific way of determining the age of a forest stand? And how would you go about doing that? And maybe it's not as simple because I'm getting some smirks, but.
No, it's very simple. I'm going to let Matt answer that. Did you say determining the age of a forest stand?
Yeah, how to determine the age of a forest stand.
Well, you know, there are definitely some ways of going about that, not just one single approach, but I would say probably the tried and true approach would be using dendrochronology. It'd be extracting wooden cores from trees where you can count the rings and get age counts on trees. If you do so in such a way that's statistically rigorous across the stand where you're not biasing your sample, you can get a better sense of what the age structure of that forest is by just aging the trees themselves based on their rings. At least in our temperate forests, that works fairly well.
And just to add to that, I mean, some very easy ones, white pine, 1 whirl, 1 year. So you could just, a white pine is a nice indication of how old at least that white pine is, but by implication, in many cases, the age of the forest, not always. As Matt mentioned, you can go further. You can actually look at how the forest grew and how individual species grew in relation to each other over time, succession, by taking adjacent individual trees and sectioning them up at different heights and seeing at what age they reached at what height between themselves. So you can actually monitor, it's called stand development, and you can actually monitor and record the rate of growth relative to each other of how trees grew. Of course, you're just measuring the successful winners. Just remember, there's an enormous amount of failure. It's called self-thinning. Foresters thin to avoid self-thinning, but thinning in terms of nature, it's all about tree death. I hate to tell you that, but competition and self-thinning, which is what nature does, you start off with many, many small individuals and you end up with one. Okay. So that's nature's self-thinning process in terms of growing space too. So you don't get an accurate picture of self-thinning. You have to have permanent plots to try and get an understanding of that.
We can also use historical aerial photography to give us a broad brush approach. So, you know, really cite, you know, some of the things that Matt and Mark, you know, site intensive to really understand, you know, the individual trees that are there. But we can look through time to see kind of a temporal profile when that forest, you know, succession, you know, started to occur. But we only really have good data back to the 1930s. So it's, you know, that's some of the earliest photography we have in the state. And so our older age forests extend, you know, beyond that. And so we have more limited information.
Great. And I think we do have a little bit of time for a few more questions, but I do want to get the climate change question in here too, in case people have to drop off at 11:30. And I know, Dr. Ashton, you started to mention this a little bit, and we are going to have an entire webinar on forest and climate change. So again, this will probably not be a sufficient answer, but basically, can you give a little more, expand a little more on what you were talking about on how management can be positive for carbon sequestration with regards to respiration, et cetera, and anybody else, please jump in as well on why management and how active management, even though it may sound, at least at first, counterintuitive, could actually be positive for capturing carbon.
Well, there's a couple of principles here, right? As I mentioned, self-thinning. That's probably the most efficient way of maximizing carbon sequestration over time, because self-thinning is competition between individuals, and those individuals are basically usurping absolutely all resources available to them, okay? But as individuals get bigger, because of competition, some individuals are going to get weaker, some are going to get stronger, and through self-thinning, the growing space, therefore the carbon that is relinquished to those that die, is usurped by those that survive. So over time, there's going to be an incremental increase in carbon sequestration. However, it's going to, if you think about yourself, when you're smaller, think about human development. You grow fast, you sequester carbon fast, okay? But as you get bigger and bigger and bigger, you become, the amount of photosynthesis, the amount of leaf matter that you have to maintain your body size, the margin of incremental increase gets smaller and smaller, smaller. The respiration, the maintenance of your body, the living mass, gets larger and larger. The amount you can photosynthesize per unit respiration mass is decreasing all the time. So there comes a time when the amount that you photosynthesize is about the amount that you're respiring. Big trees. All it needs is a stressor to kick the bucket. Boom, climate change itself. So we assume in our predictive models that that we can continue growing bigger and bigger trees that will sequester carbon, but they in and of themselves are being influenced by climate change, are being influenced by, in terms of their respiration maintenance, that makes them much more susceptible to climate change. And also all the other stresses I talked about, insect defoliation, okay, fragmentation, disease, drought. So as you get bigger and bigger, you get much more prone to those sorts of things. In an even-aged, maturing forest that came from agriculture, the whole thing is happening at the same time. So the whole forest is being predisposed to those same threats as it gets bigger and bigger. So that there's the potential to essentially lose all of it in one go, okay? We don't see it because this is a chronic phenomena. So that's what I'm talking about in terms of trying to instigate a resilient forest first, and from that, a forest that is capable of mitigation second. And so that means lowering perhaps the maximum carbon sequestration of the level of these forests to make individuals healthier, provide more individuals more resources per individual than maximizing, okay, the numbers of individuals that are all tiny or small and much fewer resources to go to many more. And by doing that, you're lowering the carbon sequestration, but making it much more viable as a stable carbon source on the forest landscape than an unstable one. And so with the excess carbon, why not use that in building products that can be essentially substitutes for cement and steel, which cost an enormous amount of energy, much more than free photosynthesis, passive energy garnered by trees. Substitute that carbon in the built environment. Technology is now that you can build all sorts of things instead of out of steel and concrete, out of wood. I mean, it's conceptually there, people are thinking about it heavily. And I'm not saying abandon the strategy of trying to look at carbon mitigation in reserve systems and in mature forest. That is part and parcel of active management as well. But it should be embedded within an active management strategy and an inclusive management strategy. That's what I'm suggesting there.
Anybody else want to jump in? So we're good. All right. All right. Eileen, how much more time do we have for questions? Just want to flag, because we're at 32. Oh.
We're kind of at the end, but if there's one more that you think would be beneficial, we could take one more.
Yeah. So I think that this is a very large question, and it does encompass a few things, because I had a question about specific policies. And I know none of you guys are necessarily policymakers, although experts in your field on these issues. So I think this question hopefully can provide some ideas to that question as well when we're talking directly about policies. But in your opinion, what would active management, silviculture promote healthier / more resilient forests as compared to just preservation, and how should those two be balanced, especially with increased disturbance intensity of climate change as well as urbanization? And finally, speaking in that, can you speak to the trade-offs for managing for a single good, such as carbon, I think, which Dr. Ashton, you did specifically, as opposed to the whole potentially network ecosystem? I know it's a lot. That's one final large question, but I thought it was a really good one. And if everybody probably can jump in even on just part of that, that would be useful. And let me know if you need me to repeat any of that, because it was pretty deep.
I'll jump in. I think we really want to manage our forests for multiple purposes. Okay. And so, yeah, carbon is part of that, but water resources, we talked about it as habitat in terms of biodiversity. We really didn't talk much in terms of, you know, the water resources aspect. And so recognizing, you know, I think we do have to recognize when you go in and actively manage, there are risks involved in that, okay, that you're going to go in and disturb the forest. And so to try to do that in an intelligent fashion, in a way that you're not going to disturb the soils as much, to preserve their soil organic carbon, you know, you're not going to adversely affect the water quality and the like. And so I think we learned a lot about to do it intelligently, that you can minimize some of the others, but thinking about it from a broad perspective. And again, from a landscape perspective, some forests might be more, not treating them all the same, and thinking about where they sit on the landscape, what's been their past history, what are our objectives and goals for that particular forest in that particular location. And so, you know, you have to take a nuanced view.
I mean, I can add to that. Richard said risk. It's all about risk. Yeah, we can make predictions, okay, to the best science that we have available, and science is going to continuously change, and we're going to continuously change the arguments. I don't think our arguments are going to change in the direction. They're not going to reverse, but they're going to become more refined in our understanding of the variation that is going on and in relation to the unpredictability that's out there with all these different interactions. And so you are managing risk, and you're managing risk in the sense of an environment in a forest that is relatively unpredictable because of all these particularly compounded phenomena that are actually beyond the control of the conservation, the manager or forester, because they're compounded by all these insects and diseases and climate change and all these sorts of. And so you need to take a risk-averse strategy, trying to be as inclusive as possible. And think about it like the stock market. If you're going to be in finance, you are going to be trying to invest in a diverse array of stocks with multiple redundancy, okay? in other words, same functional group of stocks and multiple different kinds of stocks, okay, to absorb yourself of risk. And that's what I think we're all proposing in terms of a forest management strategy for New Jersey, being risk averse. If you invest entirely in saying, please, we're going to set all this forest aside, no cutting, no doing nothing. You have one asset, you've got invested in one maturation and age class and legacy of human land use that is essentially it's an all or nothing strategy that can essentially expose yourself to enormous risk. Okay, so that's what I think we're all suggesting. You need to diversify your assets. New Jersey needs to diversify its assets in terms of forest conditions right now.
All right, diversification. That's what I.
Dan or Matt, any last comments to add? I know that, yeah, Eileen, we are right on, and I know you want to give a wrap up, but any last comments to add to that? They look good. All right. Sorry, Eileen. Yes. So.
Yeah, oh no, that's fine. You know, there's so many good questions in this webinar and in the other one. I'm hoping that we can do a FAQ, frequently asked questions, to have available for folks whose questions were not answered or were not answered adequately. So stay tuned for that. But for now, thank you to all of our panelists and to Drew for coordinating the Q&A. I hope everyone can join us for our next Healthy Forest webinar in the fall, where we're going to focus on climate change and forest carbon. Also we'll have one on prescribed burning. If any of the attendees have ideas for additional webinars, we are happy to accommodate that. I heard deer management a lot today, and it appeared a lot in the question. So that could perhaps be a great topic for a future webinar. But other than that, thank you again, and I hope you can join us in the future. Thanks, panelists. Thanks, Drew.